Hey, how's it going, everybody? In this video, I'm going to go through this LeetCode number 200 number of islands. So we are given a n by n binary 2D binary grid, which represent a map of 1 representing island and 0 is the water, and we have to return the number of islands. And the island is defined by surrounded by water and is formed by connecting adjacent land horizontally and also vertically, and you may assume all 4 edges of the grid are all surrounded by the water. So before we get to the example, let's see how popular this question was. So we have almost 20,000 likes, and if you click on this button, we can see that for the past 6 months this question was asked by Amazon for 70 times, and also Bloomberg and Google and other big names. And let's take a look at the example, and we have a grid like this, as you can see. So we have ones over here and over here and over here, so they are all connected, so they are considered as a one island, right? And also there's one over here as well. This one connect to the one above, and that's why we have one island in total. And for this second example, we have one island over here, so 1 1 1 1, so they are all connected. And also we have another island because they are not on a horizontally, neither vertically connected, so this is the second island. This is isolated from the first island. And then we have the third island over here, that's right at the corner, and these two ones connected, so that's why it's a third island. And also we have some constraints over here, and we are going to solve this problem using depth first search, DFS, or another method you can use is the BFS, but I'm going to use the DFS in this example. So let's dive into the solution together. I'm going to make the screen a little bit better, a little bit bigger, and perfect. So we can see a bit better. So first we want to iterate the grid, right? So the way to do that is to have two double the for loop over here. So for the row index, right? And we can iterate all the rows over here. And also we have a column index. So for C in the range of the length of the first row, right? So this iterate all the columns, and then now we can access to the element, right? And if that element is a 1, meaning that is a island, right? So we can count the number of islands from there. Also, if that coordinate that has not been seen before, right? And then this is a new island that we have never come across. And in here we can call a DFS function that we are going to write. And also we have to implement this scene as well. And as I mentioned, if we this is a brand new island that we have not seen before, and this will add to the result, right? The result basically is a counter that counts how many islands that we have islands that we have come across. Okay, and first thing first is a scene. So basically this is a set, keep track of the coordinate that we come across before, right? And this is the the initialization, and also we have the result counter, which keep track of the again the number of islands that we have come across. And now we can implement this DFS function. So this is gonna be a function within this bigger function. And now we are coming across this island for the first time. That's why we are adding to the scene set, right? And essentially this is the element that we're adding. It's a tuple, right? So the first element of the tuple is the row index. The second element of the tuple is the column index, and that corresponds to over here. So if we go back to this function, if this tuple has not been seen before, and then we will execute the DFS function. Also we will increase the counter, And then now we are seeing this coordinate for the first time. That's why we are adding to the scene set. Okay, and now we are iterating all the directions. Remember, as we mentioned, the island are connected whenever the number is horizontally or vertically connected, right? And so we have another for loops over here, and for the direction in the row, also the direction in the column, for all the possible directions. So what are all the possible directions? And we can have a list like this that lists out all the possible directions. So for example, so this one we are going along the row index, right? So we can -1 on the row index, so step one step back on the row index, or stepping one step forward on the row index, or on the columns index, right? So this is a 4 potential direction that we can go, and then we can keep track of the next row index, right? So essentially also the next column index after we step one forward or backward, right? And within the direction of the one that we specify over here. So we essentially, once again, we are adding this direction in the R to the old index. Also, we are adding the direction in the column to the old column index, and then we will arrive to the new or next row index, or the next column index. And then we have a long if statement over here. Let me show it to you. So if the next row index that's within the boundary, and also when the next column index is also within the boundary, and also that the element that we're looking at, that's a 1, meaning that's an island. And then if the next index tuple has not been seen before, and that means this element is connected to the old element, right? So what we can do is to find so this one is a adjacent element to the old index, and now we can find a neighbor of the next R and the next C, right? And then we just essentially we have a recursion function to put it back to here, and the whole thing goes on and on until we find all the neighboring ones, essentially the neighboring ones. And that is pretty much it, and let's return it at the end. As you can see, it is pretty efficient, and in terms of time complexity and also space complexity, it's big over n. So we are essentially iterating all the elements in the grid. That's why it takes big O n for time. Also, we have a scene set that keep track of the element that we're coming across when we're iterating it. That's why it also takes big O n for space as well. Thank you so much for watching. I hope this is helpful. See you next time.